this is my final product for creative and physical computing. I've made a reaction timer similar to what you'd find in an escape room or a video game. I enjoyed creating this, and I feel like I've built a great foundation of knowledge using MaxMSN and building patches. So I will show you how the patch works. So it sends a little LED through, and then you've got a button here, and you've got to click it when the LED is on. It moves on to the next stage. There you go, so that means it's complete. So I used a lot of different sources and completed a lot of different research to help me make this patch, such as MaxFocus websites, tutorials on Blackboard, and even Max's provided help sections. So to start with, I set up the board using LED outputs and just one button input. I did this quite easily following provided tutorials. Could have created 3 separate buttons for each LED, but I feel like just using one would involve more complex patching and then display my knowledge in a better way. So firstly, I linked my LED outputs to the patch using a Blackboard tutorial. I created a metronome and added a counter and a select box that would flick the LEDs between their on and off state. After this, I connected my button input using root input analog and a variable that would check if my if my output was above 0.5, and that'd mean that the button's being clicked. Like, I'll just show you. So while you click the button, it goes above 0.5. So this is where things got a bit more difficult. I had to code my patch in a way that it'd know if the button was being clicked while the LED was on in its on state. So I created this box here after completing some research and help understanding some Max functions. And this will basically check that the number being sent through here is opposite to the number being sent through here. And if it is, it'll send a bang through, which would go up to my stage selector up here. So I copy and pasted my my original patch of what I'd just done, so that I'd got each stage, and I updated the metronome and obviously which LED output it was. Stage selector works by, it takes a number, selects, so say we're on the second stage, it'd go through here and send a 1 through here, so it'd start the timer on that, and then it'd start checking there. My biggest problem doing this was because I'd copy and pasted the patch, it was checking when the button was clicked for every single stage, even if it wasn't just the stage that the player was on. So I struggled with this stage massively and had to get my tutors to help, which in the end we added this equals 1, which was checking that it was on the right stage before the button was clicked, and we added a delay, and then it ended up working. I then connected some audio files that play when you win, and finally a victory state where all 3 lights are on. So all in all, I enjoyed this project and I'm pleased with my final result. Because I spent a lot of time struggling on one stage of the process, I didn't have enough time to fully complete what I envisioned at the start of my build. If I had more time, I would have added a lose state that occurs when you press the button at the wrong time, and I'd probably also add a way to reset the board and play again. Despite this, I think the patch shows an understanding of the application and shows the extra research I've put into the task.